guide to low voltage and limited power remains accessible for download via the link provided. This guide serves as a resource for understanding low voltage and limited power systems. Low voltage systems, as defined by the National Electrical Code or NEC, typically operate at 50 volts alternating current or 50 volts direct current or less. These systems are used in a variety of applications, including residential, commercial, and industrial settings. Examples include lighting control systems, security systems, fire alarm systems, and communication systems. Limited power circuits are characterized by limitations on both voltage and current. These limitations are designed to reduce the risk of electrical shock and fire. The NEC provides specific requirements for the installation and wiring of low voltage and limited power circuits. These requirements are intended to ensure the safety of both people and property. The guide likely covers topics such as conductor sizing, overcurrent protection, grounding, and wiring methods. Conductor sizing for low voltage circuits is crucial to prevent voltage drop and ensure that the circuit can carry the required current. The NEC provides tables that specify the allowable ampacity of conductors based on their size, insulation type, and ambient temperature. Overcurrent protection, such as fuses and circuit breakers, is essential to protect low voltage circuits from overloads and short circuits. The size of the overcurrent protection device must be carefully selected to coordinate with the ampacity of the conductors. Grounding is an important safety measure for low voltage systems. Grounding provides a low impedance path for fault current to return to the source, which helps to trip the overcurrent protection device and clear the fault. The NEC specifies the requirements for grounding electrodes and grounding conductors. Wiring methods for low voltage circuits must comply with the NEC requirements for the specific application. Common wiring methods include using non-metallic sheet cable, metal conduit, and cable trays. The guide may also address specific applications of low voltage and limited power systems such as Class 1, Class 2, and Class 3 circuits. Class 1 circuits are power-limited circuits that operate at a higher voltage and current than Class 2 and Class 3 circuits. Class 1 circuits require more stringent wiring and protection methods. Class 2 and Class 3 circuits are power-limited circuits that are designed to be inherently safe. These circuits operate at a low voltage and current and are typically used for control on signaling applications. The NEC provides specific requirements for the installation of Class 2 and Class 3 circuits, including limitations on conductor size, overcurrent protection, and wiring methods. Understanding the requirements for low voltage and limited power systems is essential for electrical contractors, engineers, and inspectors. The guide to low voltage and limited power can be a valuable resource for gaining this understanding. In addition to the NEC, other standards may also apply to low voltage and limited power systems. These standards may include those developed by organizations such as Underwriters Laboratories or UL, the Institute of Electrical and Electronics Engineers or IEE, and the National Fire Protection Association or NFPA. UL standards address the safety of electrical products, including low voltage power supplies and control equipment. IEE standards cover various aspects of electrical engineering, including power systems and communication systems. NFPA standards address fire safety, including the installation of fire alarm systems. When working with low voltage and limited power systems, it is important to consult all applicable codes and standards to ensure compliance and safety. The guide may also cover the topic of Power over Ethernet, or PoE. Power over Ethernet is a technology that allows electrical power to be transmitted over data cables, such as Ethernet cables. PoE is commonly used to power devices such as IP phones, security cameras, and wireless access points. The NEC provides specific requirements for the installation of PoE systems, including limitations on voltage, current, and power. Proper installation of PoE systems is essential to ensure safety and prevent damage to equipment. The guide likely details the various types of low voltage cables used in these systems. These could include, but are not limited to, non-metallic sheets cable, commonly known as NM cable, which is often used for residential wiring. It consists of two or more insulated conductors enclosed in a non-metallic sheath. Then there is metal-clad cable or MC cable. This cable has insulated conductors encased in a flexible metal sheath, providing mechanical protection. It is suitable for exposed or concealed installations. There is also underground feeder cable or UF cable. This cable is designed for direct burial in the ground. It features a moisture-resistant jacket and is suitable for outdoor lighting and other underground applications. Another is low-voltage landscape lighting cable. This is specifically designed for low-voltage landscape lighting systems. It is typically direct burial rated and has a smaller gauge than standard power cables. Understanding the specific application will help determine the appropriate cable type to use. The guide will likely delve into the specifics of transformers used in low-voltage applications. Transformers are electrical devices that transfer electrical energy between two or more circuits through electromagnetic induction. They are commonly used to step down voltage from a higher level to a lower level, such as from 120 volts to 24 volts for control circuits or lighting systems. There are several types of transformers used in low-voltage applications, including step-down transformers, which reduce voltage from a higher level to a lower level, such as from 120 volts alternating current to 24 volts alternating current. These are commonly used to power control circuits, lighting systems, and other low-voltage devices. There are also isolation transformers. These transformers provide electrical isolation between the primary and secondary windings, which helps to protect against electrical shock and reduce noise. They are often used in sensitive electronic equipment and medical devices. Autotransformers use a single winding for both the primary and secondary circuits. They are smaller and more efficient than traditional transformers but do not provide electrical isolation. Autotransformers are commonly used for voltage adjustments and motor starting. When selecting a transformer for a low-voltage application, it is important to consider the voltage and current requirements of the load, the ambient temperature, and the type of enclosure. Transformers should be installed in accordance with NEC and manufacturer's instructions. The guide might also talk about specific devices you would find on a low-voltage or limited power system. These devices include power supplies. These are electronic devices that convert alternating current voltage to direct current voltage and provide a stable voltage output. Power supplies are used to power electronic devices such as sensors, controllers, and communication equipment. There are also relays. These are electromechanical switches that use an electromagnet to open or close contacts. Relays are used to control circuits with high current or voltage from a low current control signal. They are commonly used in control panels, motor starters, and lighting systems. Another device includes terminal blocks. These are modular connectors that provide a convenient way to terminate wires and make electrical connections. Terminal blocks are used in control panels, junction boxes, and other electrical enclosures. Another is sensors. These are devices that detect physical quantities such as temperature, pressure, and light. Sensors are used to provide feedback to control systems and automation equipment. When selecting devices for low voltage and limited power systems, it is important to consider the voltage and current ratings, the environmental conditions, and the specific application requirements. Devices should be installed and wired in accordance with the NEC and manufacturer's instructions. The guide may also address the importance of proper labeling and documentation of low voltage and limited power systems. Labeling is essential to identify circuits, components, and wiring. Proper labeling helps to prevent errors during installation, maintenance, and troubleshooting. The NEC requires that all electrical equipment be labeled with its voltage, current, and power ratings. Documentation is also important for low voltage and limited power systems. Documentation should include wiring diagrams, schematics, and equipment specifications. This documentation can be used to troubleshoot problems, make modifications, and ensure that the system is properly maintained. Proper labeling and documentation are essential for the safe and efficient operation of low voltage and limited power systems. The guide could provide best practices for troubleshooting common issues that arise. When troubleshooting low voltage and limited power systems, it is important to follow a systematic approach. This approach typically involves the following steps. Firstly, you should verify the power supply. Check the voltage and current output of the power supply to ensure that it is within the specified range. Secondly, check the wiring. Inspect the wiring for loose connections, damaged insulation, and incorrect wiring. Use a multimeter to check for continuity and voltage. Thirdly, test the components. Test the individual components of the system, such as sensors, relays, and controllers, to ensure that they are functioning properly. Fourthly, review the documentation. Consult the wiring diagrams, schematics, and equipment specifications to understand the system and identify potential problems. Fifthly, isolate the problem. Use a process of elimination to isolate the problem to a specific component or section of the circuit. When troubleshooting low voltage and limited power systems, it is important to use appropriate safety precautions. Always disconnect power before working on electrical equipment. Use insulated tools and wear appropriate personal protective equipment. If you are not qualified to troubleshoot electrical equipment, consult a qualified electrician. The guide will likely emphasize adherence to safety practices, as safety is paramount when working with any electrical system. Always to energize circuits before working on them. Use appropriate personal protective equipment or PPE, such as safety glasses, gloves, and insulated tools. Follow lockout/tagout procedures to prevent accidental energization of circuits. Be aware of the potential hazards of electrical shock and arc flash. If you are not qualified to work on electrical equipment, consult a qualified electrician. Safety should always be the top priority when working with low voltage and limited power systems. The guide could include relevant tables from the National Electrical Code or NEC. These tables provide valuable information on conductor ampacity, overcurrent protection, and wiring methods. For example, NEC Table 310.15 B16 provides the allowable ampacities of insulated conductors rated up to 2000 volts, based on their size, insulation type, and ambient temperature. NEC Table 430.52 provides the maximum rating or setting of motor branch circuit, short circuit, and ground fault protective devices. NEC Table 250.122 provides the minimum size of equipment grounding conductors for grounding electrical equipment. These tables are essential for ensuring that low voltage and limited power systems are installed in accordance with the NEC. Consulting the relevant NEC tables is crucial for proper system design and installation. The guide may also delve into the specific requirements for fire alarm systems. Fire alarm systems are critical life safety systems that are designed to detect and alert occupants to the presence of a fire. Low voltage circuits are commonly used in fire alarm systems to connect detectors, control panels, and notification appliances. The NEC and NFPA 72, the National Fire Alarm and Signaling Code, provide specific requirements for the installation and wiring of fire alarm systems. These requirements address issues such as circuit integrity, supervision, and power supply. Circuit integrity refers to the ability of the fire alarm circuit to remain operational during a fire. The NEC requires that fire alarm circuits be installed using methods that provide circuit integrity, such as using fire-rated cable or conduit. Supervision refers to the monitoring of the fire alarm circuit for faults, such as open circuits and short circuits. The NEC requires that fire alarm circuits be supervised to ensure that they are functioning properly. Power supply requirements for fire alarm systems are stringent. The NEC requires that fire alarm systems have a primary power supply and a secondary power supply, such as a battery backup, to ensure that the system will continue to operate during a power outage. Proper installation and maintenance of fire alarm systems are essential for ensuring the safety of building occupants. The guide may also mention considerations for surge protection in low voltage systems. Surge protection devices, or SPDs, are used to protect electrical equipment from voltage surges caused by lightning, switching transients, and other events. Voltage surges can damage sensitive electronic equipment and cause fires. SPD are installed in electrical panels and at the point of use to divert surge current away from protected equipment. The selection of SPD depends on the voltage and current ratings of the system, the exposure to surge events, and the type of equipment being protected. The NEC provides requirements for the installation of SPD in Article 280. Proper installation of SPD is essential to ensure that they will function properly and protect equipment from voltage surges. The guide will likely discuss energy efficiency and how it relates to low-voltage lighting systems. Low-voltage lighting systems, such as LED lighting, are becoming increasingly popular due to their energy efficiency and long lifespan. LED lighting consumes significantly less energy than traditional incandescent lighting and has a much longer lifespan. This can result in significant cost savings over the life of the lighting system. When designing low-voltage lighting systems, it is important to consider the lighting requirements of the space, the energy efficiency of the lighting fixtures, and the control system. Lighting control systems, such as dimmers and occupancy sensors, can further reduce energy consumption by turning off lights when they are not needed. The guide will also emphasize the importance of proper grounding in low-voltage systems. Grounding is an essential safety measure that provides a low-impedance path for fault current to return to the source. This helps to trip the overcurrent protection device and clear the fault. The NEC requires that all electrical equipment be grounded in accordance with Article 250. Grounding electrodes, such as ground rods and ground plates, are used to connect the grounding system to the earth. Grounding conductors are used to connect electrical equipment to the grounding system. Proper grounding is essential for the safe operation of low-voltage systems. The guide may include a section on the use of low-voltage systems in renewable energy applications. Low-voltage systems are commonly used in solar photovoltaic, or PV, systems and wind power systems. In solar PV systems, low-voltage direct current is generated by the solar panels. This direct current is then converted to alternating current by an inverter. Low-voltage direct current circuits are also used for control and monitoring functions in solar PV systems. In wind power systems, low-voltage alternating current is generated by the wind turbine. This alternating current is then stepped up to a higher voltage by a transformer. Low-voltage circuits are also used for control and monitoring functions in wind power systems. The NEC provides specific requirements for the installation of low-voltage systems in renewable energy applications in Article 690 for solar PV systems and Article 691 for wind power systems. The Guide to Low Voltage and Limited Power is a tool for anyone working with these systems.